Ahmad Abdelrazaq is the Vice President and Executive Director of Samsung. KJ Kim, known to many of us around the world for many of the projects that he has participated in, is the project manager and much more than that for the Burj. And their topic today is construction planning process. Without any further ado, let me turn it over to them.
Thank you very much for introducing us here. And I practically, through this project, I played kind of two hats. One of them is working on the early design concept of the project. Another one is participating and still in the construction planning and logistics of Burj Dubai. Obviously, we heard a great lecture today about integration of design, and it was an interdisciplinary process, very integrated. And through the design process of this building, believe it or not, it was a very, very, very short and intensive design process. And, but at the same time, the success of this building cannot be achieved to achieve 160 floors without due consideration of the construction aspects of the project at the onset of construction, at the onset of design. So the design is not only included the design of all disciplines, but also incorporated all the construction technologies that pretty much is available to us today. And in order to achieve a 3-day cycle and achieve the construction of the project at a very tight schedule. Obviously, today I just wanted to introduce Mr. KJ Kim, who is the project director and also vice president with Samsung Construction, who has not only participated in the Burj Dubai project and construction, but he also was a project manager also on the Petronas Tower, like Bill Baker introduced. Please go ahead. He will be talking about all the construction planning that went on the design. One thing before I leave the floor to him, this building, essentially all the design process that went through, it is almost controlled by gravity design rather than wind design because of all the wind engineering aspects and studies that were made early on that Bill Baker spoke about.
Thank you, Ahmed. My name is KJ Kim, and I'm working for Burj Dubai Tower as a project director of the Samsung and B6 and Arabtech joint venture for last 3 years. I'm very glad to have this opportunity to brief on the construction planning of the Burj Dubai Towers. I have only 20 minutes. I will try to keep that. Since this presentation is the first of this session, so I include the project brief for better understandings. And after this project brief, I will talk about structural system and site logistic and key technology of the tower construction, including 3-day cycle and concrete engineering and pumping and Spire works. First is a project brief. Burj Dubai Tower has the more than 160 floors, and total building height is over 700 meters. And total built-up area is almost 480,000 square meters. And design was done by SOM Chicago, and Turner is carrying out the project management, and Haider is the supervision consultant. And as you know, this Burj Dubai is the multi-use development project, and lower portion of the tower is the hotel, and the up to level 108 is the apartment. And above that, there is 37 floors office. On the top of that office, we have the mechanical floor and communication floors. For your information, this sky lobby and observatory deck is located at the level 122, 23, and 24. And inside the tower, there is a special elevator to reach this sky lobby, the double deck elevator. The speed is 10 meters per second, so everybody can reach within minutes. This photograph shows the current progress. And we are installing this control panel at the level 101. And inside the tower, we have almost 7,000 workers who is doing this mechanical and electrical works and fit-out works. Next is the structural system. From the basement up to level 156 is a reinforced concrete structure. And above that level is the steel structure. Total building weight is the more than 500,000 tons. So underground, we have 192 numbers concrete board piles. And board pile diameter is 1.5 meters. And the average depth of this pile is the 50 meters. And easily you can calculate one pile must take the 3,000 tons. But based on actual on-site test result, it's more than 6,000 tons. So safety factor is more than 2. And we have used the 300,000 cubic meter concrete and also 55,000 tons rebar and 4,500 tons structural steels. As you can see, this floor plan is a Y-shape, and a Y-shape is ideal shape for the structural stability, and same time providing the residential perfect view. And the structural element, you can see this center core and I-shape, the wing wall, and nose column. So based on this structural concept, we developed the construction sequence and also finalized the detailed construction program. Next is site logistics. I don't need to emphasize this importance of the logistics, especially for the super tall buildings. And the logistic teams providing all the support for the actual site progress and activities. So when we plan this logistics, and we have to consider this construction sequence and movement of the manpowers and materials and cycle time and trip times, also number of equipments and or the location of the equipments. And for the smooth operation of the site, we decide to have the separate team, and they are acting like a military force. This is about the equipment plan and tower cranes and hoist and concrete pumps. I have a video, the presentation. This can give more clear pictures.
For the main tower, 3 luffing tower cranes are installed for lifting large quantities of materials quickly. 4 concrete placing booms for casting concrete more efficiently. 14 high-speed temporary hoists for transporting manpower and materials. And 3 high-pressure pumps for pumping concrete up to the highest floors are used. Furthermore, the pressure pump technology that sends high-strength concrete up to a height of 570 meters while maintaining its workability is one of the world's most advanced technologies adopted and utilized by Samsung.
Originally, our target was 570 meters, but the last month we cast the concrete up to the more than 600 meters. Next item is for the key technology of the tower construction. First, 3-day cycle. We're supposed to complete this project within 47 months. So when we analyze and finalizing our master schedule, we decide to have this 3-day cycle for the typical floors. So to maintain this 3-day cycle, we decide to use the automatic climbing foam system for the wall, and also lever prefabrication system, and simple drop head formwork system for the slab, and high performance concrete for the early stripping, and advanced concrete pumping technologies. As you can see, this is the sequence of the construction. First, we construct the center core wall, then wing or wall is followed, and after that, this nose column and slab is followed. So within this different activity also we have the outside slab activity and also inside core slabs and staircase. So to complete the one floor, we have to cast concrete for the 37 different area and zones. This video shows the 3-day cycles.
On the first day of the 3-day cycle of the construction process, steel reinforcements are pre-assembled on the ground and then lifted to the fixing area to minimize assembly time at the fixing location. On the second day, the forms are set in position after installing the door openings and steel embeds. On the third day, the concrete is poured, and after 12 hours, the form systems are automatically lifted to the next floor positions by 2,300-ton hydraulic jacks attached to the forms.
This is the section of the automatic climbing foam system. I will skip details. And we allocate the lever prefabrication area next to the tower. This picture shows the prefabricated and pre-assembled cages. And this is the drop head formwork system for the slab, and also to provide the safe working area, we install the protection screen. Next is about the concrete. Based on the structural design, we have used the grade 80 and 60 concrete for the vertical members, and also we use the C50 and 60 for the slabs. And for the better the pumpability, we have to have a very high flow abilities. For example, this C80A, we need the 550 plus minus 3 inches floors. And for the higher level, we have used the 14 millimeter coarse aggregate, and also the floor requirement was the 600 plus minus 75 millimeters. To meet all the character of the concrete, we have to consider all those points, strength and elasticity and high flowability and early strength and heat of hydration and drying shrinkage and highlight pumping. And we have used the fly ash and microsilica and crushed sand. This, especially dune sand, provide the good flowabilities. To check the design assumption and the actual concrete characters, we did the creep and shrinkage test. We have used the two laboratories. One is the CTL United States and Samsung laboratories. And this test was carried for 3 years. And test result was very close to design assumptions. Before finalization of the mixed design, we did the mock-up test, a 2.1 meter concrete column and the hammerhead walls. And we analyzed of this heat of hydration, and also through this analysis, we designed the curing method. And inside the concrete, maximum temperature was the 75 degrees Celsius. And test for the high strength concrete, and we did the another simulation to check the pumpability and also workability and the temperature of the concrete. And actually this, we installed the 600 meter length of the concrete pipelines, and we have pumped all the different grade of the concrete, and finally we find out there was a significant flow loss. So every 100 meter there's a 25 to 30 millimeters loss. And also every 100 meter concrete temperature goes up by 1 degrees. For the direct pumping to the higher positions, we have used the BSA 14,000 models and also 4 different concrete placing booms. And here you can see the 3 heavy-duty concrete pumps, and also we installed the 5 different concrete pipelines. One is for the center core wall, 3 number is for the wing walls, and 1 is the just backup if there's any problem with the pipeline during the pumpings. And if we are not able to reach the top level, then we had a backup plan, which this additional pump is located at the level 124, so we can receive the concrete from the ground level and re-pump to the designated area. But this was not happen because of this. We are able to reach the more than 600 meters. And also to check the pumpabilities, we check the pumping pressure, and every 50 meter we put the sensor and we monitor the pressure of the concrete pipelines. Now our target is the 624 meter. This will be the another world record. The previous record was 448 meter at the Taipei 101. This is about the Spire works. As you can see, this top portion of the spire and pinnacle, this tower crane cannot reach that point. So we decided to use the lift-up method. So we have the space for the spire assemblies. So inside the building, we put together all the members, and after completion of the weldings, and we have to lift up by using the hydro jack and strand. Total lift-up height will be 87.8 meters. But difficult part is during the lift-up, we have to finish the remaining structure, and also we have to install the cladding panels. This is the sequence of the installation, but I will show you these videos.
The tower with a spire structure brings the tower to the highest structure in the world. First, the outer part of the structure is constructed, and then blocks of the pinnacle pipe are assembled within the building. Then, a lift-up method with hydraulic jacks and steel strands will be employed to push the spire pipe up to its final position.
And I have few reference photographs. This is the tower crane, and this is a hoist, and this is the wing wall, and this one shows the lever installation, and the outrigger beam for the mechanical floors. And also we have this very heavy elevator machines to lift up this double deck. And this weight of the machine itself is the 24 tons, but the capacity of this motor is 100 tons. And this one is the curtinal mock-up test. This one was done successfully last May. And panel installation. And this is the view from the top. I believe you have a chance to visit the tower this afternoon. You will have more explanation from the Imam. This is the complete view.
Find me somebody to love. 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 Anybody find me?
Thank you. This is all for today. Thank you very much.